Hi everyone, today we are going to learn how to solve one-step equations by using multiplication and division. Well, we've already gone over what to do when we're adding and subtracting to solve equations. Now we're going to look at multiplication and division. Really not much difference from what we were doing before. It's kind of the same ideas, but let's take a look here. So one thing that's important is this identity property. Now here's a big word here, multiplicative, and it's kind of weird to say, but really sometimes this is referred to as the identity property of multiplication. And really all it says is 1 times any number is itself. The number keeps its identity. That's the way I remember identity properties. What do I have to do to the number for the number to remain the number itself, to keep its identity? So in our first ones here, we're not going to go through all of these, but 1 times 1 is 1, and -1 times 1 is -1. Anything times 1 is itself. That's all that big word up there, the multiplicative identity property, means. But it's an important concept as we go through solving these equations when we're dealing with multiplication and division. So again, the multiplicative identity property says 1 is called the multiplicative identity because any number times 1 is itself. It keeps its identity. Now, the division property of equality, now we've talked about addition property of equality and subtraction property of equality. Now we're looking at division property of equality, and it works the same way. Whatever you do to one side of an equation, you do to the other. So dividing each side of an equation by the same number produces an equivalent equation. So let's look at the first example here. 10 equals -2x. Now we want to get x by itself, but we got to look and see what's going on with x. It's -2x, which means -2 times x. That isn't subtract 2 from x. That's not what that means. It means -2 times x. So I want to undo multiplication. So what I can do is divide that by -2. So -2 divided by -2 will give me 1, and that's what I want. I want 1 times x, because 1 times x is still x. But whatever I do to the right side, I have to also do to the other side. And now, on the right side, I got my x by itself. It's in a positive, and it's a positive x. That's why I divide it by -2. That coefficient in front is -2, so we divide by that coefficient. 10 divided by -2 is 5. Signs are different. It's -5. And I can go ahead and check that. And if I go ahead and check that, I substitute in the value that I just solved for. So -2 times, and I use parentheses here, -5. -2 times -5 is +10. And 10 equals 10. And I can put a check right above that. Let's look at example 2. So now I look at the side where the x is, and what I have going on there is 5 times x. So if I divide by 5, that's going to give me x by itself, or 1x if you want. 5 divided by 5 is 1, but a lot of times we don't put that coefficient of 1 in front there. So whatever I do to one side, I have to do to the other. And again, we're writing our division like fractions almost. So this, we can treat it as a fraction. 21 divided by 5, that doesn't go evenly because 5 times 4 is 20s, and then I would have a remainder. But all I'm going to do is turn this into a mixed number, 4 and 1/5. And I could go ahead and check that 5 times 4 and 1/5 is going to give me that 21/5. That's all there is to that. So now let's look and a couple more things here. So the multiplication property of equality. Now we talked about the addition, the subtraction, and the division property of equality. So you can almost guess what the multiplication property of equality is going to say. Yes, it's going to say whatever you do to one side, do to the other. So if we're multiplying one side by one thing, as long as we multiply the other side by the same amount, the equation will remain balanced or equal. So here in number 5, if we look at number 5, it says x divided by 3 equals -18. So what do I have to undo to get x by itself? Well, I have to undo what's going on with it, and it's being divided by 3. So what I can do is I can multiply each side by 3. So when I do that, I'm going to put a little 3 out here. I'm going to use my dot for multiplication because we don't want to get the x mixed up with our multiplication sign. So multiply each side by 3. Now, on the left side, what that's really going to give me, and normally we don't write it out like this, but that's going to give me 3x over 3, and 3 divided by 3 is just x. Or you can just see that that's the way it's going to be and go right to x. And then 18 times 3 is 54, but it's going to be negative because the signs are different. So that's negative 54. And I can go ahead and check that one as well. So substitute in for x. Negative 54, sorry for my writing, divided by 3 equals negative 18. And you can check that with a calculator. And that does give me negative 18 equals negative 18. Check. Done. All right, look at number 6. Now, something here with number 6. You get a choice here a little bit. So 36 equals negative x divided by 4. Now that negative either goes on the x or it goes on the 4. But again, we want to get x by itself. We don't want negative 1x or negative x. So I get to choose. That x can go on the top or the bottom. Well, I'm not going to put it on the variable because I don't want it on the variable in my answer. So really, I'm just going to rewrite this as 36 equals x divided by negative 4. And then whatever you do to one side, do to the other. So in this case, I'm going to multiply this side by negative 4 because I'm undoing divide by negative 4. So the opposite of dividing by negative 4 is multiplying by negative 4. And I'm going to do the same thing to the other side, multiply by negative 4. All right, so that on the right will give me positive x, which is what I want. And then on the left, that's going to give me 144. But it's going to be negative because the signs were different. And that's the answer to that one. Okay, so let's look at another concept here. How can we get a number, multiply a number, and get 1? So 3 times what equals 1? Well, it's got to be smaller than 3, but really all it is 3 times 1/3, right? That would be the same thing as dividing by 3. And if I wanted to get to 1 using negative 6, it would be multiply it by negative 1/6. Multiply it by 1/8. You see the pattern here. Now, look at our fraction over here at number 20. Let's look at number 20. 1/4 times what equals 1? Well, how many fourths equal 1? Well, it's 4. And really, we're just taking the reciprocal of that fraction, just like we did with our numbers here. 3 could be written as 3 over 1. Anytime you multiply a number times its reciprocal, you'll get 1. And that's an important thing. So with negative 2/3, that would be 3 over 2, but it would be negative because negative times a negative is positive. That's an important thing when we're dealing with fractions, especially when solving equations. So let's look at that. So multiplying by the reciprocal. This helps us solve equations, especially when we're dealing with fractions. So look at number 7 here on the page. I'm going to scroll up here a little bit. Solving an equation by using the reciprocal. So we have 1/3 times x. So really I have to divide by a fraction. And we don't divide by a fraction. If you recall back to, I think it was chapter 2, we multiply by the reciprocal. And this is why I kept emphasizing that we need to use those terminology, multiply by the reciprocal, instead of the keep, change, flip thing that many of you wanted to do. So in this case, what I want to do is I want to get x by itself, so I'm going to multiply by the reciprocal of 1/3, which is 3 over 1. And now the other side gets multiplied by 3 over 1, which is really just 3. On the left-hand side, I end up with x. On the right side, I end up with negative 54. Let's look at number 8. 2/5. I need to get rid of that. Well, I could divide each side by 2/5, but dividing by a fraction means multiply by the reciprocal. So I can multiply by 5 over 2 on each side times 5 over 2. And I want to show you what happens here when I actually multiply 5 over 2 times 2 over 5. That's going to give me 5 times 2 is 10. Now, normally I wouldn't write this out. I'm just showing you why this works. 2 times 5 gives me 10. And 10 over 10 is 1. And those are x's. So 1x can just be written as x. Now, again, I would normally skip this step because I know multiplying by the reciprocal will give me 1 equals, now 8 times 5, remember I can put 1 here, multiplying our fractions, 8 times 5 is 40, 1 times 2 is 2, and that can be simplified to just 40 divided by 2 is 20. So x equals 20. So let's take this one step further here, or you could even say a step backwards to what we were doing before. So when you had, I'll do this in red right down here. So when we had 2x equals 10, I'm just making this up. So I could, I'm going to divide each side by 2, but I could multiply by the reciprocal of 2. And the reciprocal of 2, remember 2 is 2 over 1. I could multiply this side by 1 over 2. And I could multiply the other side by 1 over 2. So we can always multiply by the reciprocal, although we don't really do it when we have whole numbers. So that's going to give me x equals 5, which we could probably figure out just by looking 2 times what number equals 10. But I'm just showing you this extra example here, this one here, just so you know that we can always multiply by the reciprocal to get x by itself when we're dealing with multiplication and division.